Look at that plant. I want you to know that everything was grown in my garden. Don't touch that plant!
Is it poisonous?
She'll become part of the plant.
Hi, everyone, and welcome to Flower Power Garden Hour. I'm your host, Marlene, and today I am talking to an expert in a topic that I'm very confused about, I'm very intrigued about, and I think a lot of you will be as well. Some of you might have heard this term already. This may be completely new to other people. It's very exciting. And what I'm talking about and going to be talking about is something called biochar. I heard about it a few years ago. There's a lot of misinformation online, but I was at a forest symposium online and a soil scientist popped up and my ears perked up and she was talking and she's an expert in biochar. So with me is Debbie Dumroese. She is based in Idaho. She works at the Rocky Mountain Research Station for the U.S. Forest Service, and she's a senior soil scientist. And I'm so excited to have her on the podcast. So hi, Debbie.
Hi, Marlene. Thanks so much for the invitation to chat with you today.
Yeah, well, like I said, I think it's a topic that a lot of people might have heard about or not even, but are confused because it almost seems too good to be true, this biochar stuff. But like I always like to do before we get into the main, gist of the topic, I want to know how you sort of got to where you're at. Because, as a gardener, everyone who's a gardener knows that soil is, the key. So did you come from a soils background? Did you come from a forestry background or a completely other background? And just a little bit about where you're from and how you got where you're at, and then we'll get going with the biochar.
Okay, so actually, my background is in both forestry and soils.
Okay.
I got started in my research career because I was working on my master's project up in North Idaho at the Priest River Experimental Forest, and we were looking at how important organic matter is to forest soils, and so my work has just expanded on that. Those efforts a long time ago. I hate to think about how long that's been, but a long time ago, and working with land managers to improve forest soil conditions.
And is it did you do your research in Idaho?
I did, yeah. And then I moved. I'm originally from Michigan, and so I moved to Idaho after I finished my master's degree. Worked on a PhD here at the University of Idaho, and continued to work on what drives forest productivity. And I've become the leader of a North American-wide study that uses the same experimental treatments across a lot of forest sites so that we can see, where and when is compaction an issue or organic matter removal an issue, and how does that change what we see on forest sites? Does it change the understory or the overstory? Does it change below ground processes like decomposition or nutrient cycling? And so so all of that kind of still leads into, and I'm going to just switch right away to how I got into biochar research.
Perfect.
Because they're all connected, right?
Yeah.
One of the things that we've seen, particularly as a lot of our national forests have been thinning stands to reduce the incidence of wildfire and insects and diseases, is that we end up with a lot of slash piles. And then we burn those slash piles, and we have seen the impacts of those slash pile burns last for up to 5 decades on forest sites. And so that's really concerning, right? Because you no longer have that area of the slash pile that's in productivity for forest plants. Usually it's invaded with invasive species that we don't really care too much about. So my work with biochar really got started with, how can we burn slash piles differently so that we could not impact the soil so much, and maybe create a charcoal product that could improve soil health and continue to help us have forest plants. So that's it's kind of a weird segue into all of this research that's been going on with biochar, but that's kind of how it started, was with slash piles.
So the idea of biochar, when did you hear about it? And because obviously something in your head was like, okay, what if we, so you were ahead of your time, obviously, as a soil scientist, but when did you even hear?
So interestingly enough, when I first started with my research career in the Forest Service, we were working with, and my boss had been one of the leaders in work on bioenergy from forest products when Jimmy Carter was the president. So that's how long ago we have noticed that charcoal has been important for forest species. Um, but it wasn't until people started talking about the terra preta sites down in Brazil that we really started to put the dots together and really understand that it's not just this old charcoal on forest sites that could be important, but it could also be new charcoal from prescribed fires or slash pile burning or intentionally made charcoal in kilns or at bioenergy facilities that could be transported back to forest sites or agricultural soils or rangelands to really build soil health and improve, all those processes that go on below ground.
So biochar, you could say, in a sense, is the charcoal that remains after wood products have been burned. So when you burn wood, and you're talking about the slash piles, and that's sort of what the remnants of what they go through and they create after there's been fires. It's sort of like all the small kindling, I imagine.
Yep, and oftentimes when we do thinning projects, particularly on public lands, there often is not a value for a lot of the wood that's being harvested because the stands are overstocked and the material is relatively small, and so sometimes there are markets for that material, saw logs and post and pole, but whatever is not merchantable, it doesn't pay to take it someplace and do something with it. And so that's where all of it's the small materials, it's the branches.
Got it.
Sometimes it's larger material as well that are burned in slash piles. Yeah.
So then that would be burned, and we'll talk about how the process of that, but just for people who've
Mhm,
not even heard it, the biochar is sort of like when you have a fireplace going, and then you have ash, but then you
mhm.
have these pieces of um, wood that hasn't burnt completely into ash, but it is like charcoal.
Exactly. Yep.
Okay.
Yep.
Okay. And you're saying that has a lot of benefits to the forest, and
Yeah.
and it seemed endless when I was listening to your talk. It just seemed like I'm like, this seems almost too good to be. And then of course your brain starts working like, how is that even possible? And then discussing this with people, my husband's like, well, how does that work? How is that? I'm like, I don't know. I'll ask her. so, but it's not as simple. Okay, so say you have your slash pile and then you burn it and
Mhm,
you have the charcoal. Do you just burn it right there on site? I know
mhm.
in your talk you had these big kilns. Does it have to be done in kilns? Are you guys finding that that's easier to control? Better product comes out of it?
Yeah, yeah, exactly right. You can do it in a slash pile. In fact, I have 50 acres of timberland that we have been thinning and making biochar on site in small slash piles. We try to put um, some of the larger material on the bottom so that the pile is a little bit elevated off the soil surface, but oftentimes we burn our slash piles in the winter when we have a couple feet of snow, so it probably doesn't really matter here at our site. But then if you're doing it on a site where there's no snow or you don't have access to water, if you just rake out the coals when you're done so that it doesn't continue to smolder, and it's that smoldering process that really impacts the soil. And so if you can stop the smoldering, break it out and let it cool down, away from the pile, then you get some pretty nice charcoal.
Okay. And the idea behind the charcoal is that, and I'm just going to let you explain. So you have this charcoal, it's been burned down,
Mhm,
and I know
mhm.
carbon sinks is a big one. You want to
Yeah,
talk a little bit how that, and I know the soil is the soil technically the world's largest carbon sink?
pretty much. Yeah,
Okay.
yeah.
Okay. So then you have this biochar, and what is the
Mhm.
science behind it being able to be a carbon sink?
So, as pieces of wood are 50% carbon, right? And left as wood, they're really valuable on soil, but oftentimes those pieces of wood decay and the carbon in the wood that's on the soil surface goes off as carbon dioxide. into the atmosphere. So the idea behind adding charcoal is that you have this charcoal that will last a long, long time. And it will, even if you leave it on the soil surface, it will eventually work its way into the soil and become this long-term carbon sink. So that's that's really the benefit for carbon sequestration, is that it'll last. Estimates are between 100 and 1,000 years. Nobody really knows, and it depends on the soil conditions, the soil texture, how much sand, silt, and clay you have in your soil, how much organic matter is already there. Climatic conditions, so California, warm and dry, might be different than here in North Idaho, cool and wet. So so those differences kind of determine how long it lasts, but it is a long-term carbon source.
Okay. Got it. So that sort of explains the carbon function of it.
Mhm.
Sorry, I just wanted to clear that one up. And
No.
so then you're doing your burn piles. When did the idea of, well, let's get these kilns going? When did that come about?
Mhm. So, like right after,
Okay.
and there have been, there have been several companies who have tried to do mobile in-woods processing in the forest, and in fact, there are now larger pieces of equipment that will do that. But the kilns are great for small landowners because then you don't have to worry so much about the fire creeping around on your site and possibly burning up something you don't want burned up. So that's a nice way to contain it. And it's easy. You just fill up the kiln with the wood, you set it on fire. As the coals burn down, you can just keep adding more until your kiln is full. And then we've used soil or water to quench the flames, just like you would in the slash pile burning. And then let it cool overnight, come back the next morning, and you've got some really nice biochar.
So what's the optimal time and temperature, and does it depend on the wood species and how old it is and how wet? I imagine it's not, just put it in there and cook it. I'm sure there's some caveats based on how to get the best
Yeah,
product.
for small landowners or gardeners who want to make their own, you could even do it in a 55-gallon drum if you have one of those on your property. But the nice thing about it is that you'd probably want to wait for the wood to dry. We usually say wait a season and then burn it, because the trees are pretty soaked with water when you first cut them down. So yeah, you'd want to let those dry a little bit, and it burns a lot easier, right, when it's not quite so moist. It's like putting it in your fireplace.
Yeah. The temperature, do you want it to be blazing hot, or do you just want it to sort of do a slow cook, a slow burn to get the biochar versus having it go to ash?
No, the trick is that when you really build up the ash when you let the charcoal smolder for a long time. So that's what the process of that quenching does.
Got it.
You
Okay.
put out the flames, and then the smoldering stops, and you'll still get some ash, right?
Yeah.
But you won't have as much, and you'll get this nice biochar product.
Okay. So you're basically just controlling it and making it by putting the fire out, basically.
Exactly.
Okay.
Yeah.
Okay. But the kilns that you showed are huge. And first of all, how far?
Some are.
Some are. So, I mean, how far into the forest are those? And I imagine you probably had to use a helicopter to get those in? Or
So the giant kiln that I showed, it was probably 12 feet long and about 6 feet wide. Those are usually brought into, they've been using them a lot in Utah for pinyon juniper restoration activities. And so they're brought in on the back of a truck and
okay.
put in the soil and then filled with a loader of some sort.
Okay.
But there are manufacturers of smaller kilns that are more portable than that. And you can even make your own. I've seen kilns that have been made out of corrugated metal. And it's just a circle of metal placed on the soil surface, and they fill them up, and then people have made their own lids to quench the flames. But you could use soil or water or whatever you got handy. And yeah, so you can make your own. Like I said, a 55-gallon drum, fill it up, burn your wood, put the lid on, call it good.
Yeah.
Dump it out the next day.
Okay. Yeah. Obviously in the forest, you have to be very careful, and I don't recommend people just
Yeah,
do this in
yeah.
their yards. It's like having a burn pile.
Right,
Make sure
right.
you do it
Right.
smart. You're like, hey, I'm going to make some biochar, and then you burn the whole forest down. So that, so,
Yeah, that's probably not a good thing. Yeah.
so have you been doing, so the once you get your biochar, I imagine you're trying to figure out the sweet spot between, how much to add to the soil, and
Mhm.
what is your goal? It's not just carbon, but you're trying to figure out erosion and water holding. Like, what are the other benefits of adding it to the soil? What is sort of for a forest and what you're working on, what is sort of the end game?
So for forests, so let me back up just
Mhm.
a little bit. We know from a lot of research that's been done around the world that most forest range agricultural soils really have lost a lot of carbon. From land management, tilling the soil, cutting down trees, wildfire, whatever it is, they've lost organic matter. And so part of our goal is to put that carbon back into the soil and to have it last a long time. Part of it is also that soil health piece, because we know that microbes are really dependent on organic matter source to do all those things that they do, like nutrient cycling. But we've used biochar on old roads that have been abandoned to reduce the bulk density, because the biochar is so fluffy and light. You can add it to the soil, and it helps reduce the compaction of the soil. So that means once the compaction is reduced, you can increase infiltration, and the biochar is really great at holding water in the soil. And so I like to think of it as a giant sponge. The biochar is helping rebuild that sponge in the soil so that you can hold more moisture longer. We've done some work where we're able to keep vegetation green longer into the summer, which is really key in places that don't have a lot of water.
Hmm.
And it's really key for maintaining forest health, right? We can keep trees to quit. Usually trees shut down in the summertime because they just can't access soil water. But if there's water available, they stay healthier, and ultimately would be more resistant to insects and diseases and wildfire because they're healthier and can withstand those disturbances.
That's amazing. So basically it's like a big sponge. It's very porous, so it's
Yeah.
holding moisture, and it sort of as it dries, it sort of releases them. Have you added, I'm just thinking about a big forest, or you have a garden and you're trying to incorporate this into the forest. Are you
Mhm.
guys adding biochar first and then planting trees to test them, or are you actually digging this into the soil around existing trees? And how do you go about doing, I mean, I know a lot of these trees
Mhm.
have more shallow feeding roots, but how deep down are you trying to put the biochar?
So on sites that have been thinned, and all we want to do is let the trees that remain grow better, so it's not overstocked, and to reduce the wildfire risk. We're just putting it on the soil surface, and we found that, for example, in Southern Oregon, we had one big rain, and the biochar was already moving through the organic matter on the surface and down into the soil. On drier sites, it takes longer time, but yeah, so we just put it on the soil surface, because one of the keys to maintaining that nutrient cycling piece that we've talked about
Hmm.
is that the forest floor, the organic matter on the soil surface, remains intact, and so we
Okay.
don't want to disturb that if it's at all possible. But there have been some studies that have looked at putting biochar in the planting hole, or growing the tree seedlings with biochar in the root zone. So it's already there. You just plant the tree. You don't have to do any extra work, and off you go. And about 25% has been like the optimum level of putting biochar in the planting mix for tree seedlings that are grown in nurseries.
Wow, interesting.
Yeah,
So
yeah. But
so
and it's different. And I want to kind of qualify all of what I've said, in that different soil types
Mhm.
respond differently with biochar. So you can't expect the same results everywhere. That's why we've got research studies all across the Western U.S.
Yeah, and I'm picturing like a really high organic soil already, and it rains, it's gonna infiltrate and percolate into the soil much faster than if you have a really compact, if you're trying to,
Exactly.
a heavy compact clay soil that's been, grazed on for years. And if you just put it on top, that
Exactly.
might not be the best way of incorporating it.
Exactly.
But you're not really going to ruin too much by digging in. So I'm picturing larger pieces, but that doesn't sound like it. Sounds like, so after you do the biochar, and the biochar is not the ash, it's the pieces, do you grind it up or
Mhm.
you do grind it up? Or
No,
no?
not really.
Okay.
You can't. I mean, it fractures pretty easily. You can crush it if you want to. Drive over it with a tractor or whatever.
Okay.
On forest sites, it doesn't really matter. Over time, especially if there's a freeze thaw cycle, the charcoal will break apart and slowly move into the soil. We've put biochar on some slopes up to about 35%, and if there's organic matter, the charcoal just kind of gets stuck and doesn't really erode off a site. Um, on those skid trails or log landings that are steep and don't have any organic matter, then yeah, if you're decompacting the soil and mixing in biochar at the same time, that's the best way to go, because then it's right in the soil already and can do its thing. Putting it on top of the organic matter, it takes time. You got to be patient when we talk about forest sites.
Yeah.
It could take 5 or 10 years, and yeah. So go ahead.
I was just going to say, in your studies, have you, you must have noticed, I mean, an increase in microorganisms and beneficial organisms in the soil afterwards? And how long how long does that take to start building up?
So again, it differs by climate, but in general, it takes between 2 and probably 5 years before we start to see those changes on forest sites. But I have to say, in my garden, it's a whole different story.
So you do use it in your garden?
Oh yeah, of course.
Oh, okay. Okay, so go through, since this is, the Forest Service, that's great, but go through the process of what you do in your garden, and how often you apply it, and your soil types, just so we know.
Yeah. So our soil type here is a really heavy clay, and oftentimes I can't get water to infiltrate. In the summertime, it's just so dry, and so I have raised garden beds, and so it's the clay soil, and of course a lot of organic matter. And 2 years ago, I started adding biochar to my garden. It took me like 10 years to figure out I should put this in my garden soil, right?
Yeah.
Hey. But 2 years ago, I put it in my garden soil, and I have to tell you that I have not had a better green bean crop in my entire life. I had green beans for the longest time in the soil. Beans fix nitrogen in the soil, and they had big nodules on their roots, and they were fixing nitrogen, and I didn't have to water as often, and I was like, holy cow!
Wow.
It was just it was like night and day.
Did you make your own biochar from what you had on the on your property, or did you sort of take a little bit from work?
Both. I have huge bags of it here in our back lot that we use for studies, and so I was trying. Of course, I have to test and compare.
Okay.
I haven't seen any difference in the quality of my green beans yet, but I'll keep you posted.
Okay. And so you added it 2 years ago. What's like? I would be tempted to keep adding it. How do you know what the sweet spot is, and is it possible to overdo it?
Yeah, I think it is possible to overdo it. You just add too much carbon, and that carbon will tie up nitrogen really nicely, and so that's always a concern. So if you're not adding it with a compost, I would say you can't overload it. But I think my plan is probably every 3 or 4 years I would kind of dig around and see if I can see the carbon in the soil any longer, and how much I could see, and then it looks like it's getting kind of low, so I'll add some more. I probably wouldn't do it every year.
Okay. And I imagine we talked about sort of the wood species. Now, I imagine if,
Hmm.
you hear, obviously oleanders are poisonous, but by the time it's broken down to biochar, and not that it goes into the soil anyways, but that's a question, a lot of times people send me. I
Hmm.
imagine from some contaminated sites or nearby, you wouldn't. Do you find that certain wood makes better biochar, or is there some that you don't recommend? Or is that still to be seen?
Yeah, one of the key problems that we've had with our biochar research is that everybody uses a different type of wood, or wheat straw, or orchard tree, or
Yeah.
whatever it might be, and everybody's doing it a little bit different. And so the method that you use to make the biochar and the tree species are really important. And like in large facilities like a bioenergy plant, the temperature and the time that they leave the wood in their reactors will also determines biochar properties. But in general, yeah, things like madrone on the Oregon coast, probably in California too. That wood, when we made biochar, the pH was really low. Other species, if you use poultry litter, if you have a chicken farm and you make biochar out of your poultry litter, the pH can be really high. And so understanding what your soil might need, maybe the pH is too low in your soil and maybe it's too high, then you could kind of target in what kind of biochar you would want to add to that soil type. And that's really important if you're planning to grow crops, and that's how you're making money, right?
Yeah.
And so, if you're planning to grow a wheat crop and you're trying to target the pH to be just right for your wheat crop, then you would really want to understand your soil and the biochar that you're applying so that your wheat will, ultimately have an increased production. On garden sites, you can kind of control pH by adding more compost from your compost bin, or putting on fertilizer to help, compensate for that charcoal that you've added.
So that's actually an interesting point, because I've always read that fireplace ash is just
Mm-hmm.
universally really alkaline. And I live
It
in it.
is,
I
yeah.
live I live in a really high alkaline area, so I would never add it. But
Mm-hmm.
but if you get it at the biochar stage, there's varying
Mm-hmm.
degrees of pH. So it's something
Yeah,
where,
exactly.
okay, so something happens where it goes from biochar to ash that causes the pH just to go one way, versus when it's in the biochar phase, it could be acidic or more alkaline, which is really
Yeah,
interesting. Um,
yeah, yeah.
and so madrone, which is weird because that's a very acid loving plant, is as low pH. So I'll remember that.
Yeah,
So
yeah, right.
I mean, I wonder if there's a, and you guys have a list? I mean, this is because this is the way I'm thinking. It's because high pH is a huge problem in our
Right.
area, because of iron
Oh yeah.
chlorosis and everything. And a lot of people have it. Some people have it the other way, which I'm like, nah. Plants love it acidic, but there is, I guess, too much of a good thing. So I'm wondering, like, it makes me think. I live in a walnut orchard. Makes me think, oh, about walnuts. I imagine are pretty. I don't know. I mean, neutral, loving. To a slightly acidic, so that would be interesting to see, because you definitely don't want to add an alkaline biochar to your soil if you're trying to help out your soil pH.
Exactly. But the thing about it is, if you know that your biochar is a pH that's relatively high, if you compost it
Mhm.
for a year or a couple months, you
Yeah.
can lower the pH of that biochar. Yeah.
Ah, okay. Okay, so you could actually, okay, so you don't need to incorporate it directly in. You could let it sit, even mix it into your compost bin. Is that what you're saying?
Yeah.
Okay.
I've done that too. Yep.
Okay. So it can be mixed. So that's good. See, these are all like implementation questions that,
Exactly.
when you think, and then you go to do it. But you also mentioned, so it's not just wood products. You mentioned chicken or poultry. Uh,
Yeah.
so not the
Yeah.
manure, but sort of the bed straw.
No, they've done both manure and the bed straw, and and a lot of that research has been done in the eastern United States with, where there's large chicken
Okay.
producing facilities and turkey facilities. Yeah.
And I imagine that the temperature is really important for that, because I imagine, you put that in your fireplace and it just directly goes to nothing. That's what
Exactly.
yeah.
Yeah.
So temperature.
Yeah.
So, okay. So people are, if they're going to want to do that, are really going to have to sort of do some research. And you mentioned the
Yeah.
big bio companies, it's temperature. And I think that's one of the, you see biochar for sale, but you don't know if you're getting good quality. And if it is just like cooked really fast, but it's
Mhm.
still the charcoal, is that is good as something that's been sort of gone through the process, I guess, quote, correctly?
I think, I think they're all correct.
Okay.
It just, the product that you get at the end is certainly different.
Okay.
And in some places like the large bioenergy facilities, in order to make their process more efficient, they chip the wood before they turn it into charcoal. So
Okay.
you do get a really fine, almost like talcum powder biochar out. Sometimes it's a little chunkier. It depends on who makes it. Um, but if you're making it yourself, you will get it'll be chunky. They're probably 2 to 3 inches, or less than 1 inch to about 3 inches in size. And so, it just depends on what you're trying to do with it, and whether you want to crush it or just leave it as it is, or mix it in your compost, and then eventually it will break down. The worms will get at it, and all that kind of stuff. So, yeah, it depends on the ultimate use for what you really want to do with it.
Okay. And then just to clarify as well, because I read things that, oh, it's full of nutrients, but basically what it's doing is it's releasing carbon slowly to feed microorganisms, and therefore that's increasing your nutrient levels because they're breaking down materials. Is that correct? Or is there
Yeah.
actually okay.
Yeah, it's not like a fertilizer,
Yeah.
right? It's not a high input of fertilization, but there are still some nutrients associated with the biochar because you don't volatilize them all off the wood. Um, but the key thing about it is that charcoal has a lot of exchange sites, and that makes it really great at keeping nutrients from leaching through your soil profile, like into your groundwater, or into a stream next door to where you're working, or something like that. And so it's holding those nutrients. Eventually, those will get released into your soil, and so it's kind of like a slow release fertilizer. Once you have those all those exchange sites loaded up with nitrogen or phosphorus or potassium or whatever you want. But yeah, so and it's also really porous, and that's why the fungi really like it. They can run their fungal mycelia through this charcoal. It's kind of a refugia. They can hide out there, not get eaten, kind of stuff. And so, it's really beneficial. And we noticed, early in my career that that's where a lot of the mycorrhizal fungi associated with trees were associated with this charcoal.
Oh, interesting. Okay. Um,
Yeah.
and can you, since now that you mentioned it, can you just explain a little bit about mycorrhizal?
Of course. So mycorrhizal fungi are fungi that form a symbiotic relationship with the tree. So they get nutrients from the tree. The trees then, send out sugars, and the mycorrhiza eat those. And in exchange, the mycorrhiza will go out and help find nutrients and water for the tree. And so it's really a beneficial relationship that, it's worth encouraging on forest sites. And so, going back to the slash pile story, that's one of the things that we found was that there were really no fungi associated with those big old slash pile burn scars. And so, restoring those is something that is really a key piece, is getting the fungi to be back in the soil again.
Oh, that's interesting that there's none there. But and that also,
No.
you're talking about the fungi, and you're talking about beans. So the beans need the rhizobium bacterium.
Yeah.
So I imagine that's why you were saying you had bigger nodules on your beans, because
Yeah, exactly.
it was probably all in the biochar just building up. So instead of trying to inoculate
Hmm.
your seeds with rhizobium, I mean, which is okay to do initially because you still need to somehow get it in there. Um, that's why you probably had such a nice bean crop. So what are some of the future studies, or where do you stand with your research in the forest, and what is like what are you currently like studying, or what are the steps, and what's the next big, I guess, study you guys are going to do?
So currently, we are trying to determine if these additions on the soil surface or in the mineral soil change the way insects move around in a forest. And it's not just the insects that attack trees, but it's also the beneficial insects. So does it change how the quality of pollinator species, so that you have more pollinator insects attracted to the plants? And wouldn't it be great if that were the case, then you could put this next to a grape orchard and increase pollination, kind of things. So that's one area of focus. We're also really interested in termites, and how does biochar change termites in forest sites? Because we know that termites, eat up wood and help the decay process. But do we ultimately change how they move through the soil because they don't like to be in contact with the biochar, or they love it and actually do more decay work? So those are some of the immediate questions that we're working on. But in the long term, some of the things that we really have to get our arms around is what I mentioned before, is that we need to have some standardized experiments that look at one, biochar used on a variety of soils across the United States, and then some local biochars. Which ones might be the optimum for whatever the soil might be, and really dial in application rates. Right now on forest sites, we say, yeah, you could apply biochar up to 10 tons per acre and have no detrimental effects. But we don't know if that's, if we could actually dial that in a little bit better depending on the climatic regime or the soil properties. And so, those are some key things that would help. And that would help us do a couple other things. It helps us then figure out where would be the best places to put biochar, and how long do we expect it to last. And then, as the carbon credit markets start to develop, how can understanding where the biochar is and how long it will last and how much you apply, how can that help landowners get credit for sequestering carbon below ground?
Interesting. I'm going back to the pollination. So where are you guys doing the study on the pollinators?
So we're actually doing it in the Midwest,
Okay.
because the public was not real keen on seeing a lot of log landings from harvest operations right next to their roads, and it was close to a couple communities. So there are 3 national forests in the Midwest, around Missouri and southern Illinois, where they have been reducing compaction, adding biochar, and planting pollinator species to see if they can increase the number of forest pollinators. And that extent, so then I can see the natural extension of that would be, for orchard crops, or for wine, because I like to drink wine and I want to make sure that all the grapes are pollinated, right?
Correct.
So,
Self-serving
I think,
purposes, or really drive
exactly.
research. Yeah.
Yeah. So right now we don't have an active pollinator study next to a vineyard, but I could see that would be something that a lot of farmers might be interested in. And there has been some work in Europe doing that exact thing, and they found that just increasing the number of pollinator plant species, flowers and things that attract pollinators in, is one way to get pollinators to move then into their orchard crops.
So you're working, it sounds like you're working a little bit with private landowners.
Yeah.
Okay. I know here, I work at the UC Davis, and a lot of, the pomology researchers, they work with existing, orchards around. So I figure that was the same thing. I mean, it's sort of a win-win. I mean, it doesn't sound like there's, you're just sort of like tweaking and trying to figure these things out. So, but yeah, I was wondering about the pollinators, because I was picturing this conifer forest of just a lot of wind pollinated plants. Not that there's not other ones on the understory, of course. But I was just
mhm.
trying to figure out if it was, you just had an orchard of some sort to just really see what the impact would be.
Yeah, yeah, and in forest sites, it's a lot of it is as pollinator insects are moving through the landscape, can we provide some little oases that could be used for, or can we connect these log landings or skid trails with pollinator plants so that we can support those beneficial insects as they move across the landscape, from forest to agricultural lands or from north to south, on their migration routes.
Yeah, I'm just trying to. I'm also thinking, I'm like, oh, I wonder how, because everything's connected, and you think, okay, would this somehow help out the bee population? Um,
Exactly. Yeah. Yeah.
and I mean, obviously, if you have a healthier soil, uh, better water retention, you're going to have less stressed plants, and then so I guess everything goes together eventually. It'll make that complete
It
circle.
does.
Are you,
Yeah.
or do you have any research areas in California right now?
I do. I do.
Okay.
Yeah.
Okay.
On the Stanislaus National Forest by Arnold, California,
Yep.
which is,
Yep. Just east of me.
you know,
Yeah.
um, uh,
Southeast.
okay. Yeah. Yeah.
Mm-hmm.
Yeah.
Mm-hmm.
Yeah.
I mean,
Yep. We visit it every year.
okay. You might have heard California has a little thing called wildfires. I mean, not that Idaho doesn't, but uh,
Yeah.
yeah. And I've gone to enough conferences and heard enough conferences where, forest management just, I mean, you go to a forest talk and it's really all about forest management and how, and I, obviously you've worked for the Forest Service, so I'm not going to, it's the powers that be. I don't even know who's in control, but, years of bad forest practice based on whatever reasons, good intentions, then turned out not so good
Yeah.
intentions. So between our drought, which is causing a lot of, the bark beetle problems and decimating our
Mhm.
forests, and a lot of, when I go up to the forest, there is so much, I guess, slash piles or just
Mhm. Mhm.
debris. I mean, you see where these
Mhm.
areas where
Mhm.
they have logged and pulled things out, but it's a mess. So is the idea
I know.
to go and clear those, which I don't even know how that would be possible to, I mean, clear all that out, but that would be the goal, to get all the biochar made, I imagine.
Yeah, yeah, so we understand that it's really important to leave some large pieces of wood on the forest site for that long-term input of organic matter. But oftentimes we have way too much of this debris left, and we don't know what to do with it, right? And so, yeah, so a lot of our work has been really focused on how can we, in woods, how can we make this biochar, and then at what point does it become a way to help rural economies build? Here's a tool for making this biochar, and we want 5 or 10% left on that site, and then the rest could be sold, to community gardens or agricultural producers or whatever. We've come to think of this as it's an organic matter distribution problem. There's too much on forest sites, and there's not enough on agricultural or degraded mine lands or other degraded soils. So how can we make this trade, right? And what's
Yeah.
the best way to do that? And that's really where a lot of our work has been focused, is how do you do this on site and be able to help people make profit out of this biochar while also sequestering carbon and improving soil health. And
And-
so, it could be a win-win-win all the way around.
Yeah.
We just have to kind of figure out some of the mechanics of how you would do that.
And that's, I think, why I was asking about the helicopter, because I know I've heard from certain loggers and people that it's really access to those sites.
Yeah. Yeah.
Getting out off of even the dirt roads where there's just so much debris and it's not feasible
Mhm.
to go out there and haul it away. So same idea would be, how feasible is it to even go and bring one of these biochar kilns, or if it's not a kiln, how do you do it on safely, I guess. You know,
Yeah.
we do get snow every few years. We get snow. I mean, last year I don't think there was any snow.
Right?
Yeah. So I guess but then you have to work against the weather when there is snow. So I guess that's what I was thinking. Is there sort of streamlining how quick it would be to get these kilns in there, how fast it could be with
Mhm.
as little detriment as far as access roads needed and that.
Right. Yeah, so the kilns, I think the kilns are more of, I mean, even the large kilns are really more of a small scale operation. What we've been working on in the Forest Service has been some more mobile units that are on wheels, and that you can create, so many. I don't know how many, but there's a lot of these air curtain burners, and so they force a curtain of air over the top of the flames to keep the smoke and particulates within the area that you're burning.
Okay.
And so it's like a big box. It's kind of like the box kilns, but it has a curtain of air over the top, and make charcoal. And we've got a patent now with Air Burner Incorporated, and they have produced a demo model for us. And and there's another company that also has something that's more mobile. So if you can move the wood in the forest to one location or several locations within that forest stand, then you could easily make charcoal and make it in quantities enough that you could then pay to transport it, within a watershed or to a local agricultural field.
Now getting a little bit into more of the business and politics, what is the incentives for logging companies to, if they were to make biochar after they are done logging, or if they go in and even do it for the forest, or do we, that's where you're saying, it's getting it out into the market. What would the
Mhm.
incentive for some of these, logging companies that maybe aren't even logging that much?
So it's another income stream, right?
Yeah.
I mean, it's a way for them to have another, as a public land agency, we don't really want these slash files, right? We don't want, it costs us to burn them.
Mm-hmm.
So if loggers are treating that material and making a product that they can sell, that's great.
Okay. I just wasn't sure if the research, wasn't sure if it was like, yeah, we know this is, dialed in enough that I'm not going to say that you trust loggers, but logging companies, but if it's still like, no, we're not quite sure we want this wood. We're not quite sure this is the way to do it. But it sounds like the research has, I mean, it sounds like you guys know what you're doing, and it sounds like it's a great thing. It's just now, like you said, getting it where it could be done at a slightly larger scale, and then fine tuning it, like how much to add per acre. What was the number you gave per acre?
Yeah, so we've been putting out 10 tons per acre.
10 tons.
I mean, you think that's a lot, but it's really not.
No.
It's like 3 or 4 inches across the soil surface, right?
That's, I mean, that seems like a lot. When I tell people to add 3 to 4 inches of compost or mulch, they think I'm crazy, and that's just in their soil bed. So, 3 inches across an acre, that's good coverage. That's not just pixie dust.
Yeah. Well, and so then if you think about it, how many acres do we have, and how much biochar could we make, and how much could we put in the soil to sequester carbon? I mean, the numbers just start to boggle your mind.
Yeah. Yeah. I mean, it seems like there's a lot of debris, but then and it lasts a long time. So that's the good thing, is you don't have to apply it every year. So if you were to add the 3 inches on an acre, would you consider that site done for decades?
Yeah, you're done. Yep.
You're done.
Mm-hmm,
Okay.
Mm-hmm.
Okay. And
Yep.
I think that's what's great about it, is you don't have to I mean, like compost, you have to reapply every year, every couple seasons. Right. I mean, just adding it once and it's reconditioned the soil, that's pretty amazing. Yeah. And like you said, though, you are talking about Forest Service soil that already has, some organic debris on top, but still that's phenomenal. Then you think, well, yeah, if we could get our forests cleaned up and added, that just, but yeah, there's a lot of acreage. Do you know of any like corn farmers and farmers in Midwest who are already using it in their soil?
Yeah, a lot of the early work had been done in agricultural soils, and we
Mm.
forest people kind of glommed onto it a little bit late, but yeah, a lot of the work has been done in agricultural soils, and even in the Columbia Basin in Washington, there had been some work on wheat farms, and they, the soils are relatively poor. They added, I can't remember, it was probably about 5 tons per acre of biochar, and they were able to increase wheat yields by 30%.
Wow.
you
Wow.
yeah, it's huge.
Yeah.
And part of the problem with a lot of farmland is that they've become more and more acidic, and so they don't grow. They become marginal lands,
Hmm.
and so adding biochar helps raise that pH back up. And they've been able, they can increase productivity just by changing the pH in the soil. That doesn't even include changing the water dynamics, so you don't have to irrigate so much, changing the nutrient dynamics, so maybe you don't have to add fertilizers often or as much. And so I think it's great. And I think we've seen a lot of small landowners make this biochar, put it in their compost, and then put it on their pastures, so they don't have to irrigate their pastures as often. They can keep their forage green longer into the growing season, and they don't have to fertilize. So that's a savings if you're a small landowner. We've also been really working with people to think about using it in livestock pens, because biochar absorbs all the nutrients from the manure, and then you could use that as an organic fertilizer on your lands. And, so there's a lot of ways that you can use this to really benefit your soil.
Wow, that's amazing. I mean, for me, the number one would be water retention, and then followed
Yeah.
by of course the nutrients. And so I'm gonna try it out. I'm gonna make my own.
Excellent.
I'll do it with the metal drum. I'm not, I'm very
All right.
hesitant to have any open flames and properties anywhere. I don't, yeah. But it sounds amazing. Where can people read more about it? Do you have some sites that you recommend?
So a lot of the research that we put out, it from the Rocky Mountain Research Station, is located on the Rocky Mountain Research Station website, and you can type in my name, and all of my publications are there.
Okay.
And it's easy to find
Okay. And hopefully I'll put it.
whatever information you might be
Okay.
interested in.
I'll put it in the show notes so people could find that, and I'll just tag.
Great.
Yeah. Um,
Working with a person in Oregon who makes and sells smaller sized kilns, and we're in the process of just doing a how-to booklet.
oh,
And
great.
so for small landowners. So
Okay.
when that comes out, I will let you know, and
Yeah.
you can let other people know. Yeah.
Yeah. Well, this is great. This answered a lot of my questions that I had. I think it answered a lot of people's questions who probably have heard of biochar, and then for people who have not heard of biochar, it almost makes me feel very optimistic, which doesn't happen a lot in, with everything you hear is sort of doom and gloom, but the fact that we have the resources, we have the knowledge, we have the data supporting how great it is. The fact it's
Mhm.
almost like one and done to a certain extent, obviously.
Yeah.
And, we have hopefully the funding to continue the research, and, with everyone
Mhm.
getting on board, farmers, and hopefully you don't get any, backlash from the funding.
Yeah.
It's actually something that it's nice to hear some optimistic news
Yeah.
about stuff.
Well, and the nice thing is, so USDA has several agencies. Another one is the Natural Resource Conservation Service, and they are all in on biochar and putting compost in the soil. And so they actually have a program that right now is just an initiative and only in some states, but they're paying farmers to put biochar in their soil,
Good.
and they also help small woodlot owners pay for equipment to make biochar on site and put that biochar back in
Wow.
their soil. So, there's a lot of programs, and the Agricultural Research Service is also part of USDA, and they have people working on the agricultural side of it. So, we're trying to get our arms wrapped around this whole biochar issue from a lot of different fronts.
Yeah, and I wish I could have gotten you in touch with the I don't know how many acres of walnuts, mature walnuts they just pulled out of the ground because they pull them out every so many years, and it's just these piles of walnut wood
Hmm.
sitting there, and
Yeah,
they're burning them, and and the nice thing is I'm sure they're burning, and just by accident I'm sure biochar is happening. Um,
yeah, yeah.
but it just depends on how, and I'm sure some of that will get tilled in. So I like to think that,
Right.
but as how much yeah, I mean, biochar happens, right? That could be your bumper sticker.
Yeah.
Even by
Right.
accident, it's going to happen when they're burning these piles. But if it was done efficiently, I can't imagine how much biochar they would have. And um, but it's still that knowledge needs to get out,
Right.
and I know sometimes it's cost effective. It's probably just easier for them to just burn it and clear it because they're trying to get the next orchard in. So maybe one day every farmer, every orchard owner will have a way of doing that, so what they pull out can
Yeah,
go back
and
in.
if you have, I've heard of some farming operations in the East where they're making biochar from corn stover or wheat stover or woody debris, and they have a set up where they're making heat and energy as well. So they're using the energy produced for their farm operations. They're heating barns where they have cattle or pigs or chickens or whatever, and so it's kind of a closed loop system where they're just recycling the materials from their farm into the heat and energy. They're making biochar as a byproduct. They're putting that back on the soil, and so there are lots of options.
Yeah, that's amazing. With the cost of everything going up, I that might drive more people to be interested in doing that because it makes a lot of
Yeah.
sense if it could be set up um relatively low cost. But yeah, that's amazing. That's great to hear. I wish I was capable of doing that at my place.
I know, right?
I know. It's like, I mean, I guess everyone is capable of, but it's just getting the right stuff. But that's great to hear. Well, I appreciate you taking the time out to talk. I'm sure as soon as I'm done, I'll have a bazillion other questions and be like, oh, why didn't I ask that? So you may get a few emails from me
Just let me know.
just clarifying. So but yeah, everyone, I hope you enjoyed listening to this episode. And I hope now if you had questions about biochar, it's cleared up. Or if you'd never heard about it, I hope you're now intrigued and thinking about at least maybe adding it to your soil, or thinking about your soil a little bit more, how it's, it is actually so beneficial to your garden. So until next time, everyone, happy gardening.